Hello everyone. Today we're learning about sectors and arc lengths, segments, and chords. So a sector is a region enclosed by two radii and an arc. Okay, so radii is plural for radius, so more than one radius. So if this is a radius and this is a radius, and this from here to here is the arc length, then this area, this shaded area in here that I'm coloring in is called a sector. Okay, a sector. Now, that's if I'm considering that this is the part of the sector that I'm dealing with. In a big circle like this, if we have a small piece of pie out of that circle, then that's called a minor sector. But I could have the exact same circle over here, and if I'm considering that there's my radius again, but from here to here is the arc length, all the way around from here to here, okay? Then if that's the arc length, then the sector I'm dealing with is this big sector, and that's called a major sector, whereas the other one is called a minor sector. And similarly, this is called the minor arc length, and this is called the major arc length. Okay, now we can have those sectors begin anywhere and end anywhere on a circle, just so you know that we don't always have to start at this position to create our sector. So this could be a minor sector here, and this could be a major sector here. Okay, so the arc, as a little note, if you weren't sure what an arc is, because arc is in our formula up here, an arc is part of the circumference of a circle. Okay, so secondly, let's move to what a segment is. Okay, a segment is a region between a chord and an arc. Okay, so what's a chord? A chord is a line segment joining 2 points on the circumference of a circle. Okay, so here's a circle, here's 2 points on the circumference of that circle, and this is the line segment. A line segment is a straight line that joins 2 points together. Then this line here is called a chord. All right, so a chord again can be any size. If it goes directly through the middle of a circle, that chord is called the diameter, isn't it? Okay, and the diameter would split that circle in half. But a chord can be anywhere, joining 2 points on the circumference of a circle. All right, so moving on to our two new formulas that have to do with arc lengths and sectors. Okay, so arc length formula. Arc length equals theta times radius. So this cursive lowercase l represents arc length. All right, so what was arc length? Let's go back and look here. Arc length is the length of the arc of part of a circumference. So it could be a minor arc or a major arc length. All right, so arc length is represented in our formula by the lowercase cursive l. Theta is an angle measurement. It must be in radians. That angle measurement must be in radians in order for this formula to work. Okay, and r is the radius. Let's do an example. Find the arc length of this. All right, so because they're showing theta right here, that means the arc length we're looking for is this minor arc length, the smaller arc length that's in that circle. So we're going to use this formula. Theta must be in radians, and this angle is in radians, so 3 pi over 4, multiplied by the radius, which is 8. And we'll leave that in simplest exact form, which will include that pi. So this is 24 pi over 4, which is 6 pi. If it was a calculator question and you wanted to know roughly how long that is, you could do 6 multiplied by pi to get an estimated value. But the exact value is 6 pi. So the arc length, so the length of this arc from here to here is 6 pi. All right. Secondly, the area of a sector formula. So again, here's our formula. These two formula are in our formula booklet, by the way. So theta, again, is an angle measurement. It must be in radians in order for this formula to work. And r, again, is the radius. All right, so find the area of this exact same diagram that we had in the last example. Find the area. That's what we're doing here, of the sector. And it's referring to this sector, the minor sector, because it didn't state otherwise, and the angle is there. All right, so area equals 1/2 theta r squared. Fill in what we know. 1/2 multiplied by theta, which must be in radians, 3 pi over 4, multiplied by radius squared. So again, we'll leave this in exact simplest form. When we do this, that'll be 64. So 1/2 3 pi over 4 times 64. I'm going to do the 1/2 times the 64 because that seems like it might be an easy thing to do. Actually, 2 times 4 is 8. I'll divide that into 64, which will leave 8. I'll do it in a couple different steps for you, though. So the 1/2 times the 64 would be 32. 3 pi over 4. We could do 4 divided into 32, which is 8 times 3 pi. And so that exact answer is 24 pi. So there we have sectors, arc lengths, and 2 new formula to be able to use.